we are saying whether you freeze one variable and then allow the other variable to change. Okay, so if in this process what I'm going to get, I'm going to get a function of by when I'm fixing x, and if I'm fixing y, I'm going to get a function of x. Okay, so this process, within this process what we can do is we can first work with the limit when y is going to a fixed number b. So now this function, for this function what we have done, we have fixed x and then thinking of it as a function of y, and then we compute the limit. Okay, this limit is in the sense of a single variable function. Okay, and then whatever quantities for this limit we are getting, this is going to give you a number for each x. Okay, so in a way what we are going to get here, a function of x, and then that I can compute the limit of when this is now becoming a function of x, so I compute the limit x goes to a. Okay, now I could have done this other way around also. I could have taken the limit with respect to x first and then y later. Okay, and when you have three variables, there are going to be x, y and z. So when you want to freeze two variables, so that will give you the function of the third variable. Okay, so in that, I mean, that is how you have to do it. Okay, so the natural question you would ask here, that what are these limits and what is their relation with the limit which we had defined earlier when the points are taken simultaneously, and is there any relation between these two also? Okay, so basically what we are saying, if we interchange the order in which we are computing these two limits, does it make a difference? Okay, so that kind of question you can always ask, and one has to be careful because generally this makes a difference. Okay, so these things are called iterated limits. Okay, so let us try to see some examples. Okay, so as I said, one can ask that what happens, that are these guys going to give us the same answer or they are different. So we have to work out certain examples. Okay, and the second question also, as I said, I mean, one has basically three limits with us. Okay, so you have to can we say that if this limit exists then the other two exist, or something like that. Okay, so all combinations you have to work out, and here I am just going to discuss couple of examples which will give you some glimpse that what kind of questions you need to ask and how to address them. So look at this example here. Okay, this is a very nice example, you will see it often. Again there is a problem here because this is x square plus y square in the denominator and x square minus y, so this is 0 by 0 form, so that point you have to to consider it separately and define, let's say here that the value is 0 at x comma y equal to 0 comma 0. Okay, so we want to understand what happens to the iterated limits. Okay, and also we want to understand that what happens to the limit when the function we are treating as of two variables. Okay, so let us first freeze by. Okay, so you take by to be non-zero and allow x to approach 0. all right, so in this situation now x is approaching 0, that means this is not 0, so that means the definition of function is given by this expression. So you are basically looking at x square minus y square and then this thing. Okay, now y is non-zero, so when x going to 0 you can directly substitute over here x equal to 0, correct? So this is going to become minus y square by y square, x is just 0, and this gets cancelled because this is non-zero term, and I am getting that for all non-zero y's this guy is just constant 1. Okay, so if I apply the limit with respect to y, that by going to 0, because this function is behaving this is just constant, not just behaving, it is a constant in the whole neighborhood of the point y equal to 0, so the limit is also going to be minus 1, correct, the same constant. So if I perform the limits in this order, x first and then y later, I got minus 1. Okay, now you can easily see that because of this minus sign over there, if I change the order I am going to get plus 1, correct, because now this by part will go away and then you will have x square by x square, and which is going to give you 1. Okay, so this is telling you that the change of order can make a difference. Okay, so they are not always same. So this example tells you that whatever you want to do, you have to do that. You cannot just always say that, you know, I just compute this limit and then the other limit is the same. Okay, so one has to be careful. And this limit, okay, try to show that it doesn't even exist. Okay, so this is also an example where the iterated limits exist but the simultaneous limit does not exist. Okay, you should also now think or ask question that, okay, in this particular example the iterated limits were different. Can it happen that they exist and are same, but even then this limit does not exist? Okay, and then try to ask the other way around, that suppose now this exists, what will happen to the iterated limits? Can we say that they will always exist and they will be same? Okay, so these are the questions which you need to think, and if you think about it, you will try to, you know, you will understand it in a much better way. Okay, so I have given a small hint here to get this part. What you do is, because you know, we know that the limit has to be unique if it exists, so just take two different paths, y equal to x and y equal to 2x, and see if this you know, leads to two different answers. If that happens, then you are going to get that the limit does not exist. Okay, so you know, you have to work with examples and then try to see the, you know, the things depend on, because now you have more than one variable, so this thing that, you know, which variable you are going to deal with first can also make a difference. Okay, so yeah, this example basically is telling us that the two things are need not be same. Okay, so this idea of considering one variable and then keeping the other variable fixed, you know, this gives rise to the notion of partial derivatives when we try to you know, compute the derivatives of that function of single variable. Okay, so I take a small break here and discuss the partial derivatives in the second part.